Alright, here's example number 4. Hopefully by now you're getting a hang of some things to look for. In this problem, to me it looks like the right side is more complicated, so we might want to start with that. I see some issues here going on with conjugates. There's also the fact that we have two separate fractions that we might want to consider combining into one fraction. We also have cosecants that we might possibly want to change to sines, but I don't think that should be our first priority on this problem. Let's get some other simplifying done first. Okay, so let's go ahead with the idea to get a common denominator and combine those two fractions together. So this fraction, in order to get the common denominator with both of these parts, is missing this. So I would multiply the top and the bottom of this one by this denominator so that I'm getting that common denominator. And then this fraction would be the other one. So the cosecant x minus 1 on the top and the bottom. So therefore I'm multiplying by 1 so that I'm not changing the value of anything. Multiplying by 1 doesn't change anything but how it looks. Okay, so on the top of the fraction I'm going to go ahead and distribute 1 times cosecant, 1 times 1. So that will give me cosecant x plus 1. And then here I'm going to actually distribute the negative with the 1 with this. So negative 1 times cosecant is negative cosecant x. I meant to draw an x, not an alpha. And then negative 1 times negative 1 is a positive 1. So there's the top of our two fractions now added together, or subtracted, whichever way you want to think about it. Just, it's really important to realize that that's a positive. Then let's go ahead and FOIL this part out. So that will give us cosecant squared x minus 1 for our common denominator, because these are conjugates. So when they're FOILed together, the positive 1 cosecant x and the negative 1 cosecant x will cancel out of the middle, and we end up just with this. Okay, now let's go ahead and simplify the top. So it looks like this cosecant and cosecant will cancel. So we'll just have a 2 on the top of that problem there. So 2 over cosecant squared x minus 1. Let's see. This, I think, is some sort of identity, isn't it? Well, at least we have, let's just do a little side note here. My little side thought bubble. The identity we learned the other day for our Pythagorean identities had this one, 1 plus cotangent squared equals cosecant squared. So if we take that one and subtract it over there, we then have cotangent squared x equals cosecant squared x minus 1, which is what that is. So we should be able to just use this Pythagorean identity and change this to that. So let's do that. So 2 over cotangent squared x instead. Well, now keeping our goal in mind, we don't want it to be cotangent, we want it to be tangent, but that's easy because 1 over cotangent is tangent. So I think we're done. I think we've got it. Right? With our reciprocal identity.